welcome back to Maths in an Empty Classroom with me, Mr. Southern. This is part 2 of the lesson on recurrence relations, and in this video I'm just going to go through a second example. So we have a sequence is defined by x1 equals 1. Now I mentioned in the previous video that where we used a, that you could also use x or u. This hasn't changed, it's x1, so this still represents the first term. xn plus 1 equals a, xn plus 3. So xn plus 1 is the next term and xn is the current term. And we're being asked in part A to find an expression for x2. So x2 would equal a lots of x1 plus 3. That's using the definition with n is 1, n plus 1 is 2. However, I'm given that x1 equals 1, so what I can do is I can say, okay, a times 1 plus 3, so x2 is a plus 3. Show that x3 equals a squared plus 3a plus 3. Well, to get x3, I'm going to do a lots of x2 plus 3. x2 is a plus 3, I've just worked that out, plus 3, and if I expand that out, you see that I get a squared plus 3a plus 3 as required. I'm going at a decent pace here because once you've got the hang of this, it is very, very repetitive. It's recursive. Now, given that a3, I should say x, I apologise. Given that x3 equals 7, find the possible values of a. Right, x3 equals 7. Here's my expression for x3. So what I'm going to do is I'm going to make that equal 7 and solve to find the possible values of a. Now that's important, that values means there's going to be more than one. Makes sense because the equation I've got here is a quadratic, so we're expecting to get two solutions here. So it's a quadratic, so it has to equal 0. So subtract the 7 to give me a squared plus 3a minus 4. Factorise to a plus 4, a take 1, which means my two possible values of a are a equals negative 4 and a equals 1. And it's worth with these questions just checking, because sometimes you're told rather than a being a constant, which is a number, it might say that a is a positive constant. That would become value of a, and you'd have to select the one that was positive. But in this case, it doesn't say that a has to be a positive constant. It says values. These are both valid solutions to part C. Thank you.